This video is about linear regression lines. A healthy human body temperature is 37 degrees Celsius. 8 people were medically examined and the difference in their body temperature from 37 degrees Celsius was recorded. Their heartbeat was also recorded. Draw a scatter diagram for temperature difference from 37 degrees Celsius T against heartbeat H. Use a scale of 2 centimeters for 0.1 Celsius on the horizontal axis, starting with negative 0.3 Celsius. Use a scale of 1 centimeter for 2 heartbeats per minute. Based on this given information, for horizontal axis, 2 centimeters for 0.1 degree Celsius. Start with negative 0.3 degrees Celsius. This is negative 0.3, negative 0.2, negative 0.1, 0, and this is 0.5. Then we can draw this y-axis. For y-axis, variable is heartbeat with H, unit, beats per minute. Start with 60 beats. 1 centimeter for 2 heartbeats per minute. 62, 64, 68. Then we can plot the points. Negative 0.2, 63. This is 62, 64. In the middle will be 63. 0.3, 77. 76, 78. In the middle is 77. 0.2, 79. 78, 80. In the middle is 79. 0.5, 86. B. Write down the mean temperature difference from 37 degrees Celsius. We need to put data into the calculator. Click on 1, no, then 4, spreadsheet, label P, Q for the column, then type in your data. After you put all the data into this column P and Q, click on menu 4, 1, go to 2 variable stats. Double click this right arrow button. P, Q for Y list, then enter. 2 variable stats. We got X bar equals 0.025, Y bar equals 74. T bar equals 0.025. for h bar equals 74. Plot and label the point M, T bar, H bar on the scatter diagram. 0.025, 74. This is the mean point. 0.1 is here. This is 0.05. In the middle, this is 0.025. 74. Label 0.025. 74. E. Use your graphic display calculator to find the Pearson's product moment coloration coefficient R and interpret it. We can get this R from these two variable stats, 0.807 as 3 sig figures. This means strong and a positive correlation between these two variables. F. Find the coefficient of determination for the data and interpret this value. We can get R squared from regression line. Click on menu. 4, 1, 3, linear regression line. Double click this right arrow button to get this P. Q. Enter. So R squared equals 0.651 as 3 sig figures. How to interpret the coefficient of determination? We will use this, the percentage of variation or variability in Y. It's explained by X variables. 65.1% of variation or variability in Y. Y over here is a heartbeat. Is explained by X variable in this question is temperature difference from 37 degrees Celsius. G1. Use your graphic display calculator to find the equation of the regression line H on T. Go back this calculator. Slope is 22.0. Y-intercept is 73.5. So H equals 22.0 T plus 73.5. J2. Interpret the meaning of the gradient in the context of the equation. Gradient means slope. Slope equals difference of y over difference of x, which means when x increases by 1 unit, y will increase or decrease by m units. For this question, we can write down like this. When temperature difference increases by 1 degree Celsius, the heartbeats will increase by 22 beats per minute. H. Draw the regression line H on T on the scatter diagram. When you sketch a regression line on scatter diagram, make sure pass through the y-intercept and the mean point. y-intercept is 0.73.5. This is 73.5 estimate over here. Then connect these 2 points. Then label h equals 22.0 t plus 73.5. Let's go to I. Hence or otherwise, estimate number of heartbeats per minute when difference in body temperature from 37 degrees Celsius is 0.25 degrees Celsius. We are looking for this h of 0.25 equals 22.0 times 0.25 plus 73.5 equals 79 beats per minute. G1. Is it valid to use the regression equation found in part G1 to estimate the value of difference in the body temperature from 37 degrees Celsius? 1. We know the difference in body temperature from 37 degrees Celsius is an independent variable. You cannot use a regression line to predict the independent variable. So it's not valid because it's not reliable to predict t from h by using h on t line. J2. Hence or otherwise, estimate the difference in body temperature from 37 degrees Celsius when number of heartbeats per minute is 83. We are given this h equals 83. We are looking for t. So we need to make the regression equation t on h, which means t equals. Let's go back to this calculator. Make sure cursor is on an empty cell. Menu. Go to 4. 1. Stat calculations. Go to 3. This time, independent variable will be Q, heartbeat. The dependent variable is temperature difference, which is P. Then enter. We got this new regression line. This time, t equals 0.0296 h minus 2.17. We are looking for t of 83 equals 0.0296 times 83 minus 2.17 equals 0.297 degrees Celsius. Let's go to K. Find the values of A, B, C, D, and E by completing the table of ranks. This is 1, 2, so C is 2. 3, 4, 5, 6, 7, 8. These two values are equal. So 6 plus 7 divided by 2 is 6.5. A equals 6.5. B equals 6.5. For heartbeat, 1, 2, 3, 4, 5, 6, 7, 8. So E equals 7, D equals 5, A equals B equals 6.5, C equals 2, D equals 5, E equals 7. We will put this rank into calculator to get this R sub S, which is Spearman's correlation coefficient. If you don't want to erase this, you can create a new page, Control Doc, add 4, spreadsheet. This time, we will label as M and N because we already labeled P and Q for page 1.1. Then type in the rank. After you put in the data of ranks, click on this menu for statistics. Go to 1, stat calculation. Go to 3, linear regression line. Double click this right arrow button to get M. N for Y list. Then enter. We got this R sub S equals 0.778, which means a strong correlation of the ranks between temperature difference and heartbeats.